more on central angles, but looking at arc length and radian measure. If you haven't read the vocab, the I can and the whys, please pause the video and do so right now. And then go ahead and complete the warm-up exercise. You're asked to give the measure of each intercepted arc, which would be arc PQ. And then you are to look at the measure with respect to the circle that arc is located on and answer some questions. So go ahead and pause the video and do that now. Okay, hopefully you wrote that each one of these arcs measures 60 degrees, and that is correct. However, the second part of this exercise was to think about walking this part of a circular track. Would you walk the same amount on each one of these tracks? And the answer is no. And that is because the circles are similar, not congruent. So even though each of these arcs measure 60 degrees, when we examine their length, measured in inches, feet, yards, centimeters, what have you, they're clearly not the same. And that has to do with the fact that the radius, which is directly related to the diameter of each of these circles, is different. And in fact, we get larger as we move from left to right. So clearly you would be walking the furthest distance if you walked an arc measuring 60 degrees on this circle versus these other two. And that's kind of our idea today, is we're going to transition from measuring our arcs in degrees and actually measuring the length of each arc. And that has to factor in the radius of each circle. So arc length is a portion or a fraction of the circumference of a circle. The length of an arc is different from the degree measure. Arcs are measured in degrees, where arc lengths are linear measurements. So we're talking about inches, feet, centimeters, etc. To determine the arc length of a minor arc, we need to work with the circumference of the circle. And to do that, we need to know the length of a circle's radius. And there's two ways to look at calculating the arc length. Two formulas. We'll look at the one on the left first. The first one is arc length. We use S for that. Is the circumference times the measure of the angle, which would be our central angle, over 360. So it's really the fraction of the circle determined by the central angle times the circumference. And the other way we can look at this relationship is we could set up a proportion. And we just got done working with proportions in similar triangles and in trig ratios. So we can look at the arc length is to the circumference as our central angle measure is to 360. So as the part is to the whole compares to the part as to the whole. Right, I'll do a couple and then you'll do a couple. So I'm going to use that first formula, but if the proportion makes more sense to you, by all means, if you set it up correctly and do the math correctly, you will get the same correct answer. So I have my arc length is 80 over 360, 2 pi radius 10 inches. You notice these degrees are going to cancel out. I can take out that factor of 10. And I can take out a common factor of 4. So that would be 2 times 4 and 4 times 9. And then I still have a 2 and a 10 and a pi and an inch. We are getting the exact arc length, which means we're going to leave the pi in our answer. So we're not going to use it as part of our calculation. We're just going to tack it on the end. 2 times 2 is 4 times 10 is 40/9 of pi inches. And this next one, same radius but larger central angle. So I think this arc length should be longer. We have 120 out of 360 times 2 times pi times the radius. The degrees divide out, the factor of 10 divides out, and 1/36 would be 1/3. And then we have 20 pi inches, so this is 20/3 pi inches. All right, the next are for you to try, so go ahead and pause the video and compute the arc length of these two circles, giving me the exact answer. That means pi is part of your answer. Our first one, arc length is 80/9 pi inches, and arc length here is 40/3 pi inches. Right. The next one, we're not going to have the picture, and we're actually not calculating the arc length. We are given the arc length, and we are solving for something else. In the first one, we're going to solve for the exact circumference, which means, again, pi should be part of our answer. So our arc length is 4/3 pi yards, and we would calculate that using our central angle over 360 times 2 times pi times r. This whole expression here is the circumference. So that's what we want to solve for. You may want to simplify before you do any mathematics. So again, 336 would be 1/12. And you might even just want to replace this with C so that you don't do any more work than you have to. And now I can see what I need to do is multiply both sides by 12. Anything divided by itself is just 1. So I have 16 pi yards is the circumference of this circle. On the next one, we're given our arc length and the central angle measure, but we're going to determine the radius. So we have a little bit more work to do, and we're going to round to the 100th place. So I put my arc length here, my central angle measure over 360 times 2 times pi times r. This is what I'm solving for right now. Again, it might be a good idea, especially if we're doing this without a calculator, to simplify this ratio. Let's see, 9 goes into 27 3 times, 9 goes into 36 4 times. Could do a little bit more simplifying. Again, if we have to do this without a calculator. So I have 75.4, that's meters, is equivalent to 3/2 pi times the radius. We know we need to multiply by 2 over 3 pi. Anything divided by itself is just 1. Anything divided by itself is just 1. So now I have R is equivalent to, and now we need to get the calculator because we need to multiply 75.4 by 2 and divide by 3 pi. When we do that and round to the hundredths place, we get 16.00 meters. Okay, the next two are for you to try, so go ahead and pause the video and complete these two problems using the examples as models. Right. Here our circumference would be 32 pi kilometers, and our radius is 5.00 kilometers. Okay, the next big idea in today's lesson is, so what we did is we transitioned from measuring our arcs using degrees to measuring them using inches, feet, meters, a linear measurement. So think of cutting it out of the circle and pulling it straight and measuring it against a ruler. We're going to now kind of do the similar thing. We're going to measure our angle, not in degrees, but in a new measurement called radians. So it's just like choosing to measure the distance you travel, either in meters or miles. So we can measure angles in degrees or angles in radians. And just like we define 1 foot is defined as 12 inches, we are defining this unit called a radian in this manner. So 1 radian is going to be the angle. Okay, so we're measuring this angle, and it is a central angle. And what happens here is the intercepted arc has the same length as the radius. So when I take this arc BA and I cut it from the circle and I line it up, stretch it out, that this would have the same dimension as the radius. So if this is 5, then this is 5. There's a 1-to-1 relationship. That's how a radian is defined. Now, how would we calculate a radian? Well, we set up that ratio to see if it equals 1. We take the length of our arc, which we just talked about and calculated, and we put it over the length of the radius. And what we would be interested in, since we're working with circles here, is how many total radians are in a circle. So let's start with the total arc length of the circle. And that would be 2 pi r, right? That's the whole entire circumference, or the complete arc length of a circle. And then we would put that over the radius, and we get 2 pi. So there's 2 pi radians in a circle. A couple of points here. We usually do not write the units next to the radians when we're talking about it. It's usually understood. So unlike our 350 degrees or 25 degrees, we would just say 2 pi, and that radians is kind of understood. We'll write it a couple times at the beginning of this lesson just to remind us what we're talking about, but I think then we'll walk away with stopping to write the units down. All right, so now the interesting part is, well, how do these 2 pi radians relate to degrees? What is the relationship? Again, we're going to come back to creating a ratio. So we just established that there are 2 pi radians in a circle, and we know that there are 360 degrees in that same circle. If we reduce this ratio, then we know that pi radians is equivalent to 180 degrees. Or we could say 180 degrees is equivalent to pi radians. This is the conversion factor that we're going to use. And we're going to do the dimensional analysis like we would converting from inches to feet or hours to seconds. And so let's maybe write that at the top of the page here. (180) is to pi, or pi is to 180 degrees. All right, we're going from degrees to radians, so we're going to use this version of our conversion factor. We notice the degrees are going to cancel out. We can even reduce this ratio to 1/4. You could see it look like this, 1/4 of a pi. Most likely you would just see the pi in the numerator, pi over 4. And I have 90 times pi over 180. The degrees divide out, and we get pi over 2. Pi over 180. The degrees cancel. The factor of 10 cancels. 3 out of 18 is 1 out of 6, so that's negative pi over 6. Now we'll use the other relationship. Pi radians is to 180 degrees. Pi's cancel out. 3 goes into 180 60 times, so this is 120 degrees. The last one for us to do together, and then you'll try those next on your own. Notice we have the same equivalent measures, except one would be positive and one would be negative. All right, time for you to pause the video and you try these next 6. All right, and now we're going to tie it all up by going back to our unit circle, getting some information that we know. Let's do it in degrees first. That's what we did the other day. 90, 180, 270, and we can map in a couple of different angles here. This would be our 30 degree, 45 degree, and then we had our 60 degree, where we could even do negative 60 degrees. And we had our nice mnemonic here, all students take calculus, which represents all of the trig ratios being positive in this first quadrant. Only the sine ratio positive in the second quadrant, the tangent ratio positive in the third quadrant, and the cosine ratio positive in the fourth quadrant. Now we can create the same unit circle with our radian measure. This is still 0 radians, but this would be 90 over 180, which is pi over 2. This is 180 over 180, so that would just be pi. This is 270 over 360, which is going to be 1.5 or 3/2 pi. And then when we come back around, of course, that would be a total of 2 pi radians. Our 30 degrees is pi over 6. Our 45 degrees is pi over 4. Our 60 degrees is pi over 3. We're going to use those reference angles in the other 4 quadrants, just like we did with the degrees. So if I go down here, this would be my negative pi over 3, which the sine and cosine and tangent, so let's go ahead and do that. Sine, cosine, tangent. And we'll relate that back to the sine, cosine, and tangent of 60. Sine, we know it's opposite over hypotenuse, but the hypotenuse in our unit circle is always 1. Adjacent over hypotenuse, and then opposite over adjacent. So that means the sine of pi over 3 is square root of 3 over 2. Cosine is 1/2. Tangent is square root of 3. We still have all students take calculus. So now I can get the sine, cosine, and tangent of negative pi over 3 really quickly. I know the only one that's going to be positive is cosine, but the other two will be negative. All right, so given that, you should fill in this table here. First step is to provide the missing units, so the equivalent degree or equivalent radians, or this, and then fill in the sine and the cosine and the tangent. So I'll do this first one with you. We know 0 radians and 0 degrees go together. We see that right here. And we know the sine of 0 degrees is 0, cosine is 1, tangent is 0. All right, so go ahead and pause the video and complete this table, and then check your work. All right, so go ahead and check that your answers match what's on the key here. If not, then you will need to meet with Ms. Fasola during our assist and connect time.